You run the same coding job through MiniMax and Kimi, and one bill comes back 3 times bigger than the other. Both models, same prompt, wildly different cost. Both MiniMax M1 and Kimi K2. Thinking want to be your coding agent, so the real question is which one actually earns that spot in your stack. Alright, so test 1, cost. I know the objection already. You're thinking both these models are cheap enough that it doesn't matter. But run an agentic pipeline that fires 1,000 API calls a day, and that assumption will wreck your budget fast. Input and output token pricing is where this fight actually starts. I pulled the official pricing pages for both. MiniMax M1 is 0.20 per million input tokens and 1.10 per million output tokens. Kimi K2 thinking is 0.60 in and 2.50 out, and those Kimi numbers are backed by community data from artificial analysis, so they're consistent. That's 3 times cheaper on input and 2.3 times cheaper on output for MiniMax. MiniMax takes cost, and it's not subtle. The gap on official pricing is cleaner than I thought it'd be, but $0.20 versus 0.60 as input and 1.10 versus $2.50 output is a real efficiency edge for anyone running high volume work. That puts MiniMax up 1-0. I've burned through enough API budgets to know that pricing gaps like that one compound fast in production. So let me know in the comments if a token bill has ever caught you off guard. Okay, test 2, raw coding ability. If the cheaper model can't solve the hard problems, none of that cost advantage matters. LiveCode Bench is the benchmark both companies published official scores on, and it's a tough one, real competitive programming problems, not toy examples. Let's see where each model actually lands. Watch what happens on the scorecards. Kimi K2 thinking hits 76.6% on LiveCode Bench. MiniMax M1 lands at 72.6%. That's a 4-point gap, both from official model cards, with Kimi's score, backed by community data too. So the numbers are solid. 4 points on a hard benchmark is real, even if it's not a blowout. Now, 4 points is close enough that, on everyday tasks, you probably won't feel it. But on the hardest, correctness-critical problems, the kind where a wrong answer costs you hours of debugging, that gap goes consistently to Kimi. So for most work, both are capable. For the ceiling tasks, Kimi has the edge. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Kimi takes coding benchmark performance. I had a feeling the cheaper model might close the gap more than it did, but 76.6 versus 72.6 is a consistent win for Kimi on raw coding chops, and that ties the scoreboard up 1-1. Test 3, speed. This one matters more than people give it credit for. Kimi users have been complaining about it feeling sluggish in practice, which is a real workflow killer when you're waiting on a model to finish a long generation before you can iterate. Output tokens per second is the number to watch here, and it's a concrete one. So here's what the data actually shows. MiniMax M1 outputs 45 tokens per second. Kimi K2 thinking comes in at 35. That's a throughput advantage of about 28% for MiniMax. And the Kimi number comes from community measurement via artificial analysis, which lines up with those real-world complaints about it feeling slow. Faster throughput means shorter feedback loops on every single generation. MiniMax takes speed. I ran the numbers twice because the gap looked bigger than I figured it'd be, and 45 versus 35 tokens per second is a consistent edge that validates every user complaint about Kimi dragging. That puts MiniMax back in front, 2-1. So MiniMax is winning on cost and speed, but we haven't touched context window and output limits yet, and that dimension could completely change which model you actually need. If Kimi's ceiling is high enough on long, autonomous runs, the price and speed gap might not matter for your workflow, and then there's deployment to check. Test 4, context window and max output. The failure mode is this. You're running an agent on a large codebase. It hits the output token cap mid-generation, and you get a truncated response that breaks your build. That's not theoretical. The max output limit is the one that bites you hardest on long autonomous coding runs. I went through the official model cards for both. Kimi K2 Thinking has a 256K context window and a 64K max output. MiniMax M1 is 200K context and 16K max output. Kimi's specs are cross-checked against community data from artificial analysis, and they hold up. That 64K versus 16K output gap is 4 times bigger, which is a massive edge for long autonomous generations. Most everyday coding tasks won't push past 16K output tokens, so for short to medium jobs, MiniMax's limit is totally fine. But the moment you're doing long agentic runs, generating full files, or running multi-step refactors in one shot, that 64K ceiling from Kimi is the one that keeps the job from breaking. For those workflows, the gap is real. Kimi takes context and output limits, and the output gap was bigger than I figured it'd be. A 4 equal larger max output is the thing that decides whether a long autonomous coding run completes or truncates, and that's a pretty meaningful spec difference that ties the overall score back up 2 to 2. Test 5, deployment and modality. This one could matter a lot if one model locked you into a single platform or dropped image input support. Shipping a pipeline that needs both text and image inputs and then finding out one model doesn't support it is a bad day. Let's check what both actually give you on availability and input types. Both MiniMax M1 and Kimi K2 Thinking are available via API and on Hugging Face, and both support text and image inputs. Kimi's modality support is confirmed by community measurement from artificial analysis, and it's consistent with the official cards. There's genuinely no differentiator here. Same deployment options, same input types, same story on both sides. The one thing worth flagging is that MiniMax has a fragmented product set up in practice, with separate code, hub, audio, and API console products, which adds friction when you're trying to wire things together. And Kimi has its own usability quirks like over-eager autonomous actions. But on paper, the deployment specs are identical, so neither model wins this one. Deployment and modality is a tie. I thought at least one difference would show up in the specs, but both models land on API plus Hugging Face with text and image inputs, identical across the board. Final scoreboard, MiniMax 2, Kimi 2, 1 tied. Okay, so here's where MiniMax clearly wins. It's 3 times cheaper on input tokens and 2.3 times cheaper on output, which makes it the obvious pick for high volume or agentic workloads. And at 45 tokens per second versus 35, it's meaningfully faster, which means shorter wait times on every generation. Cost and throughput both go to MiniMax. Now here's where Kimi clearly wins. Its 76.6% on live code bench beats MiniMax's 72.6%. So it's the stronger model for correctness critical coding, and the context and output limits aren't even close. 256K context versus 200K, and a 64K max output versus 16K. For long, autonomous agentic runs, Kimi is the only one that doesn't hit a wall. If you're running high volume or agentic work and cost is the constraint, MiniMax M1 is the smarter default because it's 3 times cheaper and a good bit faster. But if you're doing complex, correctness critical coding, where a 4x larger output limit and a higher benchmark ceiling genuinely matter, Kimi K2 Thinking is worth the premium. One thing the docs don't spell out: cache token pricing is unpublished for both models, and that matters a lot for agentic pipelines that reuse context repeatedly. So if you're building a workflow that leans on prompt caching to cut costs, you're flying blind on both sides until you test it yourself. And if you want to see how these coding agents stack up against models from a completely different corner of the market, I ran the same kind of breakdown on GLM versus DeepSeek, and that one gets into some genuinely interesting territory on raw performance versus cost, where the verdict there is way less obvious than you'd think.